Okay, so this is a second topic, which is about the formal charges and the implied lone pairs. Okay, so there's the first topic, and formal charges, and the second one is implied. So they don't need to show the lone pairs, but you just have to figure out the lone pair that's supposed to be there. Okay, and the first question here is, this is the first question. This is a topic number 2. First question is formal charges. For the structure shown below, the nitrogen atom has a formal charge. And if there's a charge, draw the charge. So you need to figure out the formal charges. The way that I count this is, let me show you the regular way, which is a formal charge. Number of valence electron nitrogen is 5 minus, how many lone pairs do you see around this nitrogen here? You see 4. And how many bonds do you see? You see 2 bonds. So there are 4 electrons in the bond, but only half them is being counted. So therefore, this is a 5 minus 6. That is a minus 1. So this is a minus 1 charges shown up here. So that's the formal charges on this. And so does the second one here, the formal charges. 5 for the neutral nitrogen, and you see 2 electrons in the lone pairs, and then half of there are 3 bonds surrounding the nitrogen. That's a 6 electrons. So 5 minus 5, that's a 0. So this is a neutral. The last one is here, which is a formal charge. 5 for the neutral nitrogen, 5 valence electron. And how many lone pairs? No lone pairs. And half of 4 bonds. So 8 electron in the bonds. That's what I meant. So that means 5 minus 4. That's a plus 1. So this one is a plus 1. So those are the formal charges of the nitrogen surrounding it. We have exercised it as we done before. You count the number of electron lone pairs and the bond electrons, and then 5 is being neutral. If you have a more than neutral 5 electrons, then that's a minus 1. You have a less than neutral electron, which is a 5 electron, then you start to develop the formal charges. There's another shortcut way. I hope you can think about, you remember this our exercise before. If you see this unit, this one is a formal charges is minus 1. There are 2 different ways, and this is a very similar drill here. Okay, so the number 2, implied. Okay, what is implied means when they draw this, it's pretty typical for them to draw like this, and we do know that based on the natures of this molecule drawing, we know this. For example, this is an sp2 carbon. This is actually sp3, not carbon, oxygens, and this is also sp3. So those are the hybridization. That's sp2. So you kind of think that in mind. And what is important here is that they want you to essentially draw the lone pairs. Okay, so this lone pair is, the nitrogen should have a 1 lone pair because there are 3 bonds. This one has 2 bonds, so remaining is there are 2 lone pairs. This one is actually 1, 2, 3 lone pairs. Okay, so that's what you have it over here. And this is acetate, and that's 2 lone pairs to be no formal charges. This one is actually, I think that there's some typo here. There's oxygen here to be a molecule, and then you should have something looks like this. Oh, okay. So that's an acetate, but I think that what this meant is they are actually trying to show it to you that this is a possible. This is a carbon ion that it looks like. So in this case, I think that I want to draw this one, and I better need to draw this molecule. So this is a little tricky. Okay, so this one is oxygen, 2 lone pairs, and this is a hydrogen, carbon, with 2 hydrogens and the lone pairs. So that makes this carbon has a -1. So when you have this carbon ion, the way that the carbon do not like to have to develop the negative charges is because it is not so electronegative. So these 2 lone pairs would like to form the double bonds. When they form the double bond, this another double bond can be a push. So by doing so, you can start to develop oxygen, can develop negative formal charges where carbon here can form the double bond, and they form the double bond, and they form this molecule. So this is actually the correct structures by essentially having a resonance structure stabilization. Instead of developing the negative charges on carbon, we can develop the negative charges on oxygen, and that will be a good thing. So I think that to complete the answer, this is we know there's a carbon here, and there is a lone pairs, because that makes this carbon has a -1 charges. Once again, let me just show you for the first and last time. Formal charges for the carbon is 4 electrons minus how many? 2 in the lone pairs, and then half of how many bonds surrounding the carbon? There are 3 bonds, 6 electrons. So 4 minus 5 is -1. So that's why this -1 charges in this environment. Okay. All right. Okay, I think that this is end of it for understanding the implied lone pairs, essentially trying to understand. And particularly, this is an organic chemistry related issue, so you will see that more concentrated on discussion on C and O, and these are the 3 main atoms that constitute the organic chemicals, and some halogens and then some other compound, but mainly the carbon, nitrogen, oxygen make up a variety of the functional group that we're going to talk about in the next section.